Last couple of lessons were all about working on timeline indicator component and making it update its position every second. And that logic actually involves quite a few calculations, which is the reason why our timeline indicator component has grown in size drastically. So in this lesson we're gonna try to refactor this component by moving the main part of the logic responsible for calculating percentages into a separate file. We're going to create another composable and extract in there all the logic responsible for calculating the position of the timeline indicator. So let's start with copying the file with one of the existing composables, for example, progress.js. We're going to call new file SecondsSinceMidnight.js, and from here let's just remove unnecessary stuff and leave only import of our new composable function, which we will rename on useSecondsSinceMidnight, like so. And now we're going to slowly extract the logic from the timeline indicator component and move it to our new composable function. So let's start from the top. The first thing that we have to move is declaration of reactive variable SecondsSinceMidnight, along with these two hooks onActivated and onDeactivated, because these two hooks are responsible for managing our timer, which updates indicator position every second. Let's just paste all this code inside useSecondsSinceMidnight composable function, go back again to the timeline indicator component, and move the rest of the logic. So we'll also extract SecondsSinceMidnight in percentage computed property along with watch effect, and this helper function calculates seconds since midnight. All of that will go inside the new composable function. And by the way, the declaration of this helper function calculates seconds since midnight can be placed outside of the composable function, since this function does not rely on any reactive features of Vue. The same thing we're gonna do with all the imports. Let's copy all these imports from here and paste in the file with the composable function, and then go back to the component and remove unnecessary imports such as watch effect, onActivated and onDeactivated hooks, as well as these four unused constants. And this way our component has become much leaner, and as we can see, only one property is highlighted, that is this seconds since midnight in percentage computed property, because this property is now managed by our composable function. So we're gonna have to export this property from the composable function in order to make it accessible from outside in this component. But before exporting this function, let's just rearrange the code inside of composable function a little bit. So we're gonna move seconds since midnight in percentage computed property closer to declaration of seconds since midnight reactive variable, since this computed property depends on seconds since midnight reactive variable. And this way it will be easier to see that these two variables are actually related. Then let's also move this watch effect function closer to seconds since midnight reactive variable, due to the same reason, because it depends on this variable. So now we can see that seconds since midnight in percentage is not used in this composable function, because it is supposed to be used outside in our component. So just like we usually do, in order to make some properties of the composable function accessible from outside, we have to export those explicitly. So right here, when we return an object from this composable function, let's include this computed property seconds since midnight in percentage. And right after this, let's switch over to our component timeline indicator, and right here, let's write down an import statement, which will import our new composable function from the composables folder like this. So down here, let's use this composable function, let's call it, and the structure return value. From here we should receive reference to seconds since midnight in percentage computed property. So after doing all this refactoring, And taking a closer look to the implementation of this component, we can see that this component manages only one thing, and that is the offset, how much indicator should be shifted from the top of the page. And the variable which stores amount of pixels by which we should shift our indicator to the bottom is called top offset, which actually depends on the percentage of amount of seconds passed since midnight up until this moment. But there are a lot of calculations involved in order to calculate the value of this percentage, and that is why we have extracted all this logic in a separate composable function. In this way, we made this component much easier to understand, without cluttering it with all the extra logic. So now we delegate all the calculations of the percentage to this SecondsSinceMidnight composable function. And now we just have to make sure that after doing all this refactoring, we didn't actually break the behavior of the indicator. So as we can see, it still functions properly, and its position is updated every second, based on the calculated percentage value, which is now calculated by using composable function. Link to the source code of this project, as always, will be in the video description. Now that we have moved most of the logic responsible for updating the position of our indicator in a separate composable function, in this lesson we're going to consider another approach, how we can achieve the same thing, but maybe the new approach will be more applicable to our case, because we're going to have to listen to time updates every second from other components, for example from the component that shows label of the hour. Because once our indicator reaches this hour becomes active, so therefore this hour label should be highlighted. So let's do the following. All the logic we have earlier extracted into a separate composable function. Now we're going to create the new file for the global module, which is going to store all the logic related to updating the time every second. So I'm basically going to move this composable file into the source folder and rename it on time. So now we're not gonna use composable function for this, but instead global module, and which is why we need to remove declaration of the composable function in this file, as well as return value of this function, since this is no longer a composable function, but a global module. But still, our timeline indicator component needs to know percentage of amount of seconds passed since midnight up until this moment, which is why we're gonna have to export this computed property. So let's add an export keyword right in front of this declaration. And since we're now located inside of a global module, not in one of the components, we cannot use lifecycle hooks of the component, such as onActivated and onDeactivated in this file. So I'm going to extract the logic of these hooks into a separate functions. Let's create the function which is going to start the timer to update the time every second. And instead what we'll do in the component is call onActivated hook, passing reference to the function which should start the timer like this. And the same thing let's do with the function inside of onDeactivated hook. But in this case, the function name will be stopTimer, and all this function will do is basically call clear interval to stop the timer. And then we're gonna call onDeactivated, passing reference to this function. So now let's move both of these hooks calls inside of the timeline indicator component. Of course, both of these hooks should be imported from the Vue package. And now, since we are no longer using composable function to get SecondsSinceMidnight in percentage computed property, we're gonna import this computed property directly from our global module time. We can do this because earlier we have added export keyword in front of this declaration. So switching back to the timeline indicator component, and there is no need to call this composable function anymore. So let's remove this line. And also remove imports of hooks onActivated and onDeactivated from time module. But instead, as we can see inside the timeline indicator component, we're also referencing new functions from the time module, start timer and stop timer. So we also have to add imports for those. Let's do it right here. And looks like I forgot to export this function from the global time module. Let's go back to this module, scroll down to these function declarations and add export keyword. And just to see if these functions are going to be called in the appropriate times, I'm going to print something to the console in both of these functions, so we can make sure these functions get called. And there is one more thing to do before we can check it in the browser, and that is fix the path to the constants module, since this module is located on the same level as our current module. We need to use one dot in this path. And now we can switch over to the browser. And now after loading the timeline page, in the console we're supposed to see one log, which is start timer. This works, and once I'm gonna switch the page, the timer should be stopped, so another log should appear in the console. As we can see, it's working properly, and when going back to the timeline page, the timer should be started again, and the appropriate log should appear. So everything is working in this case. Now I'll just go back to the editor and remove those helper console log statements from these functions, start timer and stop timer. And at this point, let's finish this lesson. The link to the repository with this project will be in the video description. In this lesson, we're going to improve implementation of our new global module called time that we have created in the previous lesson. So, since main purpose of this module is to keep track of the current time, we have to actually store the current time as a reactive variable in this module. So let's create new reactive variable and call it now. As an initial value for this reactive variable, we're gonna use current time object, like so. And actually the reason we need to make the current date reactive is for other components to be able to listen for changes in this reactive variable and respond accordingly. For example, the component which shows label of the hour. Anytime this hour becomes current, we have to highlight this hour label. But now as we can see, this does not happen and the previous hour is highlighted instead. Alright, let's keep working on the global time module. In here, we also have to know the date of the previous midnight. So let's create new variable, midnight. This will be a computed property, which will in turn depend on the reactive variable, which stores current date. And the way we can get the date of the previous midnight is as follows. First of all, let's create new date object based on the date object that corresponds to the current date. And then by calling setHours method on this date object, we can reset values of hours, minutes, seconds, and milliseconds. And this way we're gonna get the date which corresponds to the previous midnight. Then let's also move the declaration of SecondsSinceMidnight reactive variable down here, right under SecondsSinceMidnight in percentage computed property. These two things are tightly connected, so I prefer to keep both of them together. So now that we have two reactive date objects, one corresponds to the current date and another one to the past midnight, we can use computed property to calculate SecondsSinceMidnight value. And the way we can do so is by subtracting the date of the past midnight from the current date and dividing resulting value by 1000, which is amount of milliseconds in 1 second. And this way we're gonna receive amount of seconds passed since midnight up until this moment. And it looks like now that function calculate seconds since midnight, which is declared in here, is never used. So we can freely remove this function. I also prefer to group all the variables and functions which are exported from some module together and move all other private variables and functions to the bottom of the file. And here's another cool thing we were able to achieve by using this refactoring. If previously we had to keep track of the changes inside of SecondsSinceMidnight reactive variable by using this watch effect function call in here, because we had to reset the value of this reactive variable whenever a new day begins. But now, since we have turned SecondsSinceMidnight into computed property, we no longer have to keep track of changes manually, since Vue will do it for us, because this computed property depends on other computed properties such as current date object as well as date object that corresponds to the past midnight. The value of the SecondsSinceMidnight computed property will always be up to date. So we can remove this watch effect. And also we have to handle a couple more changes inside of start timer function. So previously we have removed function calculate seconds since midnight. And just because the main source of truth now is reactive variable which stores current time, which is variable now, right before starting the timer, to update this variable every second, we have to reset value of this variable and set it to the current date like this. And inside the closure of setInterval function, now we will update the current date in the following way. So we will create new date object based on the previous date object. We'll get the amount of milliseconds in the date object stored inside now reactive variable and then add 1000 milliseconds. And this way we're going to make the date stored inside now reactive variable always match current date. But for testing purposes for now, let's add 5 minutes instead of 1 second to the current date, so we could see how our timeline indicator moves down. And this way we have multiplied 5, which is 5 minutes, by 60, which is amount of seconds in 1 minute, by milliseconds in second. So at the end we're passing amount of milliseconds to the date constructor and get new date object which corresponds to the current date. As we can see in the browser, we're still seeing how our timeline indicator moves down every second and all the computed properties are properly updated. So our main source of truth, which stores current date, is reactive variable now. And this reactive variable is updated every second, because that's how often we update our timeline indicator position. And also we have declared a couple more additional computed properties which are used in some calculations, such as the computed property midnight, which stores the date of the past midnight. And then this date, as well as the current date, are used to calculate seconds passed since midnight, which is also going to happen every second. And eventually, seconds since midnight in percentage will be recalculated every second as well, because this property in turn depends on another property seconds since midnight, which is recalculated every second. So as we can see how by using only one reactive variable, which gets updated every second inside setInterval closure, leads to updates of all these computed properties. And eventually we are receiving this computed property seconds since midnight in percentage in the timeline indicator component to use this property in the calculation of the offset, how much we should shift our timeline indicator down. And the way we're doing it is basically using this top offset computed property as the value for the property top of the element which renders timeline indicator. And this is actually how we were able to achieve this illusion of moving timeline indicator, by basically making its position depend on the current time. At the end I'm going to go back to the global module time and from here remove all unnecessary imports. At this point we're finishing this lesson. The link to the source code of this lesson will be in the video description. In our project there are a couple of components that need to react on time updates, and since we update the time every second, those components should listen for time updates every second and do necessary actions. So for example, let's consider this component which shows label of the hour. So when this hour becomes current, this label should become purple. So we need to listen for time updates from within this component. Let's switch over to the editor, open up that component. It is called timeline hour. and in here we can see the constant called classes, which stores all the CSS classes that are being applied to the root element of this component. But the problem is that this expression is not reactive, so it is run only once when current component is created, but then it will never be reevaluated again, regardless of time changes. So we're gonna have to turn this whole expression into computed property, and inside of this computed property we need to reference reactive time to make this computed property be updated along with the current time. So in here, instead of receiving the current hour by calling this function current hour, we need to reference our reactive object which stores current time, which is this object called now. So let's get the current hour by referencing reactive date and calling method getHours. Then let's scroll up and change an import of current hour function on the import of the computed function. And then we also have to import our reactive object now from the module time. And now we're gonna make this list of classes react on time updates. And the way we're gonna do this is by simply wrapping this whole expression into computed function, and this computed function will be reevaluated every time reactive date object will change. So that means that this array of classes will be reevaluated every second, since our reactive date object updates every second. So now in the browser, once our indicator reaches the next hour, which means the next hour will become current. In this case, the corresponding hour label should become purple, and right away we can see desired behavior. So let's continue. Another component which should also react on time updates is timeline stopwatch component, and this is the component which renders the following stopwatch. So when stopwatch is running and the hour changes, the stopwatch should automatically be stopped. So now let's see how we can achieve this behavior. The whole stopwatch logic is encapsulated inside this composable function useStopwatch, and there is this isRunningState variable which stores value true when stopwatch is currently running, otherwise false when it is stopped. So we can watch for changes in this reactive variable by simply using function watchEffect right here. And we're gonna have to check a couple of conditions in here, and if both of these conditions will be true, in this case, we're gonna have to stop the timer. So first of all, we'll have to stop the timer if an hour of the current timeline item object is not equal to the current hour, which we can get by calling getHours method on our reactive date object now. So if current timeline stopwatch does not correspond to the current hour, and if this stopwatch is currently running, in this case, we're going to call function stop, which will stop the timer. The implementation of this function is pretty simple. As we can see, it just stops the timer by calling function clearInterval and updates value of the reactive variable is running. After updating this reactive variable, interface should be properly updated and stopwatch will be stopped. So we just have to import reactive date object now. Let's go up and write down an import statement. We're importing this object from the module time. And now let's switch over to the browser and test this whole behavior. So I'm going to start this timer, and now let's wait until the new hour will be current. And as we can see in this case, our stopwatch was stopped automatically. This is exactly what we are trying to achieve in here. But in addition to that, we should also disable the button of the previous timer and make this button active for the next timer. So in this timeline stopwatch component, let's find the place in the template where start button is rendered. It is in here. So here we need to change the condition which is used inside of this disabled attribute. As we can see in here, we're still calling the function current hour to get the current hour, but the problem is that this current hour function does not reference our reactive object which stores current date. So this function does not have reactive behavior. But in order for Vue to update this part of the UI reactively, it should be dependent on the reactive variables. So instead of getting the current hour by calling this function, we need to reference our reactive object now and get current hour by calling getHours method like this. So now let's scroll up and remove unnecessary function current hour, switch over to the browser and test it out. I'm gonna start this timer, wait until the new hour starts, and right away we can see that the start button was disabled for the previous stopwatch and it has become enabled for the next one. So from now on we will be able to start only that stopwatch which corresponds to the current hour, because all other start button of other stopwatches will be disabled. And at the end of this lesson, I'm also going to do a couple of changes inside of timeline items module, because currently in here we're still referencing that function current hour, which does not use reactive date object. So instead of calling this current hour function right here, let's reference our reactive date object and get the current hour by calling getHours method. And also let's do the same change one more time in this place. So now we just have to update the import by replacing current hour with now object. And this way current hour is no longer used in our application. So let's switch over to the functions.js and remove declaration of this function. So one more time, let's make sure that we haven't broken anything by doing those changes. Let's start the timer and wait until the new hour begins and make sure that the timer was stopped, as well as the button was disabled for the previous stopwatch and it was enabled for the next one. The link to the repository of this project will be in the video description. In this lesson, we're not going to add any new functionality to our application, and instead we'll focus on improving some parts of our existing code. And first of all, I prefer to make this indicator move down a little bit slower, because currently every second it's moving down by the time which corresponds to 5 minutes. So let's change it, and every second this indicator will move down by 1 minute. So we need to make this change in the global module time.js. Let's scroll down to the place where we are registering timer which executes every second. So right here we need to change these numbers, since we'd like our timeline indicator move down by 1 minute every second. We'll replace these values with the constant seconds in minute and multiply this value by milliseconds in second, and this way we'll achieve desired effect. So before checking this out, we have to import the constant seconds in minute in this file, and now as we can see, timeline indicator moves down much slower. Next, I would like to focus on another aspect related to the component, the timeline indicator. So let's open up this component in the editor, and right here we can see two hooks on activated and on deactivated that manage the timer, which updates a reactive variable responsible for tracking the current date. But I think this component, the timeline indicator, is not really the best place to control the timer, which updates current time every second. Because looking at our application, we only need to listen for time changes every second while we have timeline page open. So the timer starts every time we switch over to the timeline page, and it stops when we leave this page. And therefore, let's just move that logic responsible for starting and stopping the timer into the timeline component. So I'll cut these two lines from here and move them inside the timeline component, like this. But as we can see, this component already has an activated hook, so we need to combine these two function calls, scroll to current hour and start timer, into one closure, like this. And then let's remove this second call of an activated hook. And then we have to import some of the additional functions, such as start timer and stop timer. So let's go back to the timeline component and add an import statement for start timer and stop timer functions. And also we are referencing on the activated hook, so let's add an import for this hook. And inside the timeline indicator component, these hooks are no longer used, so they can be removed. So now we just need to make sure that our timeline indicator will continue going down once we're gonna come back to the timeline page. And as we can see, after I'll switch pages, timeline indicator still moves down. So everything is working. Let's improve another thing. And in particular, what I'd like to focus now on is nowItem component. This component is responsible for rendering, navigation, menu items. And what I'd like to do in here is that when we are located on timeline page, and then we'll click on the timeline menu item, I would like the page to be smoothly scrolled to the timeline item, which corresponds to the current hour. So I would like to achieve the same behavior that currently happens whenever I click on the logo component. As we can see, the page is scrolled to the current timeline item. So let's go back to the editor. And in this nowItem component, we can see that we have click event listener registered in here. And once click occurs, we call navigate function. And also let's take a look at what happens when we click on the logo. Let's go to the logo component. And right here, as a listener for the click event on the logo, we are using handleClick function, which besides navigating to a different page, also checks if we are currently located on the timeline page. Instead of navigating away, we're going to scroll the page to a current timeline item by using scroll to current hour function call. Alright, so let's use this function implementation as a reference for our handler inside nowItem component. I'm going to copy over this function, paste it inside nowItem component, and in addition to checking if we are currently located on the timeline page, we also have to check that nowItem object corresponds to the timeline nowItem, because current nowItem component is used to render all navigation items, not only timeline item. So additionally, we're gonna check if property page of nowItem object matches name of the timeline page. We're going to call the function scroll to current hour, which will scroll the page smoothly to the current timeline item. Otherwise, we're basically going to navigate to a different page by calling navigate function. But in this case, since we not always will navigate to timeline page, we have to use the page which current nowItem object corresponds to, like so. And all we have to do now is to specify the reference to this handleClick function inside click listener in here. So now let's import all missing pieces in this component, such as scroll to current hour function, as well as page timeline constant. And now there is also one more change that we have to do in order to allow clicks on the active navigation item. And that is remove this CSS class pointer events none, which disables all clicks on navigation item. Since now we're gonna allow clicking on the active navigation item, so let's remove this class. So it's time to test the whole thing in a browser. I'm going to navigate to a different page and then come back to the timeline page. Scroll down, and now if I will click on the timeline navigation item again, I'm supposed to be scrolled to the current timeline item. That is exactly what we are seeing. Our behavior is working. So now, if we're going to click on the active navigation item, as well as on the logo while being on the timeline page, the page will be automatically scrolled to the current timeline item. So let's continue working on our project in the next lesson, and the link to the source code of this project will be in the video description. By now we don't have a way to save our progress, and all the time that we will track, as well as all new activities we're gonna add, they will be lost after we refresh the page. So we're gonna have to do something about it. And one of the solutions that I would like to implement next is to sync the current state of our application with the local storage, so that next time when we open up this application, all the state will be restored and we can continue tracking our progress further. But before getting to integration of local storage with our application, let's switch over to the module time.js, and right here, for testing purposes, when we are assigning current date to the reactive variable now, before assigning this current date, I would like to reset amount of hours as well as amount of seconds and set these values to 0. This way, the modified date object will always correspond to the midnight of the current day. It will be just easier for us to test our application if timeline indicator will always start from the very top of the page. And also every time we're gonna come back to the timeline page, since we start the timer to track the current time by calling this start timer function, we're going to reset the current date to the midnight by assigning newly created object date to the reactive variable. Because just a second ago we mutated this date object to match today's midnight. And after doing all these changes, we will see the following result. First thing that we see in here is that our timeline indicator starts moving from the very top of the page, from the hour 0, and in addition to that, it will also start moving from the very first hour whenever we're gonna come back to timeline page from a different page. And now we'll get to the main part of this lesson, and that is start working on the integration of local storage. And for this, I'm going to create a separate module. Let's call this module storage.js, which responsibility will be to communicate with the local storage of the browser. So in here, we're gonna have to define two main operations. Firstly, we need to load data from the local storage to restore the state of our application. And also, we need a way to save the data back into the local storage whenever user closes the tab with our application, or he goes to another tab, which will make tab with our application inactive. And of course, we need a way to detect when tab with our application will become inactive, or when it will be completely closed. So let's switch over to the main module of our application, main.js, right before we create Vue application. So in here, I'm going to register a listener on the document object, and the event that we need to listen to in this case is called visibility change. This is a default browser event, which will basically be fired whenever current tab becomes inactive or active, or it completely closes. And to determine if the tab has become active or inactive, we can do by checking visibility state property of the document object, and if this property will be equal to hidden, that means the tab has become inactive or closed. So right before closing, we need to save the state of our application. So we'll call function save state, which we will define right here. And this function is going to communicate with our module storage in order to save the state of our application to local storage. To be able to call these two functions load and save from the main module of our application, we have to write down an import statement. And in here, I'm gonna group all the exported functions under the name storage, like this. So now let's decide which data we actually need to store in a local storage. Since our application works with two types of resources, timeline items and activities, therefore we have to store both of these resources. we're going to store them in one object. Let's create an object with two keys, timeline items and activities. And to both of these keys, we're gonna assign corresponding arrays of timeline items and activities. These arrays are reactive, because currently in our application we have two separate global modules which manage timeline items and activities separately. As a reminder, timeline item objects look like this. Every timeline item object corresponds to a particular hour of the day, and its structure consists of three fields: activity ID, activity seconds, and hour. And as for activities objects, every activity object is responsible for showing individual activity item on this page, and every activity item object consists of three properties: ID, name, and seconds to complete. From the code perspective, it looks like this. Let's go to timeline items module. Right here we can see a declaration of timeline items reactive array, which stores all timeline item objects. And similarly, we have the declaration of activities reactive array inside activities module. And since we need to get access to both of these arrays from main.js module, we need to import them separately. Firstly, let's import activities array from activities module and timeline items array from timeline items module. Next, we're going to implement save function from the storage module. In here, we are passing the data that we need to store inside the local storage as the first parameter. So we have to go to storage module and declare one parameter. Let's call this parameter data. And here we will reference local storage object. This is the object available in the browser by default. And in order to store the data in local storage, we use setItem method, which accepts the key as the first parameter under which we will store the data. Let's use our app name. I'm going to declare this constant in the constants module and assign the app name, which is on track. Switching back to storage.js, let's import newly created constant app name from constants module. And as a second parameter to setItem function, we have to pass the data that we like to store in local storage. So in here we need to specify the data which we have received as the first parameter in this function. Let's destructure the object with this data. And this way we'll get two destructured properties, timeline items and activities. Besides this, we also have to store another piece of data, and that is current date represented by string. We can get string representation of the current date by calling toDateString method, like so. Later it will become clear why we need this additional data in here. So let's go over all this implementation once again. Once user closes the tab with our application, the event visibility change gets fired, and then we execute the code inside this if conditional block, right before application is fully closed. And then this method references our module storage, which communicates with the local storage of the browser. And in here we're saving all the data in the local storage that we have passed from outside, that is timeline items and activities. And just to make sure if visibility change event will be fired whenever we're gonna close the tab or refresh the page, I'm going to print something to the console right here. And indeed, whenever we're gonna refresh the page, we will notice that word hidden is printed to the console. And now let's also take a look if the state of our application was actually stored inside local storage. As we can see, here we have additional key which corresponds to our app name, which is on track, and this key stores all the state of our application. Here we can see all the data we have specified earlier: activity objects, as well as timeline item objects. But of course, if now we're going to create new activity and then refresh the page, we will see that the newly created activity is gone, and that is because currently we're not loading the data from local storage, but only saving it. So in the next lesson, we're gonna get to the second part of this functionality, which is loading the data from the local storage when our application starts. The link to the source code of this application will be in the video description. So for now, we have already implemented saving current state of the application into local storage. But as we know, if we create new activity and then refresh the page, the newly created activity will be gone since we're not loading the state from local storage yet. So before getting to implementation of loading the data, let's recall how we have implemented saving data to local storage. So in the main module of our application main.js, we have registered listener for visibility change event, and right before the tab with our application becomes inactive or it is completely closed, this if block will be executed, and save state function is going to save the current state of our application into the local storage. As we can see, the state includes array of timeline item objects as well as activity objects, and this data is stringified before saving it into the local storage. So now we're getting to the second part of this functionality, which is loading the data. So in this listener, if the first if block will not be executed, that means that tab with our application has become active again, and we have to load the data from local storage. So let's use new function load state, which we're going to define right below. And all we have to do in here is delegate the functionality to our module storage. So we'll call method load on this object. And now let's open up storage.js and write implementation for the function load. So in here, I'm going to receive the state from the local storage into constant called state. Here we use getItem method to get the state by key. As a key, we're using appName, which is stored inside appName constant. And here, since this state will be stringified, we need to check first if it even exists, because there might be cases when state of the application will not be stored inside a local storage. So here we're using ternary expression and checking if state exists, then we have to parse it before using. So let's call method parse on the JSON object. Otherwise, we're going to return an empty state, which is an empty object like this. And finally, this data that we have just received from local storage, we have to save it in the constant in the main module where we're calling method load. And now, this data we have received, we need to assign this state to corresponding reactive variables, timeline items, which is supposed to store array of timeline item objects, as well as activities, which stores activity objects. And this way, since both of these arrays are reactive, the whole UI of our application will be properly updated, and it will display the latest state of our application, which was restored from local storage. And just to make sure we're gonna get into each of these if blocks, I'm going to write print statements, so we will make sure these blocks will be executed. So after we refresh the page, we see only one log, which corresponds to saving the state after page gets reloaded. But as for loading the state from local storage, that part of code is not executed for some reason after page refreshes. And the reason to that is because loading the data from local storage will only happen when the tab with our application will be active again, but not on the initial upload. So if I'm gonna switch over to another tab and then go back to the tab with our application, in this case we see that another part of if is executed because we're seeing the log visible. So that means data is loaded from local storage. So since the data is loaded only when the tab with our application becomes active, in addition to that, we should also make sure that we are gonna load the state of the application on the initial page load. So right here, outside of the listener, we have to call that function again, load state. So the state of the application will be loaded on the initial page load, right before our Vue application will be initialized. Let's just make sure that this is really the case. Let's put arbitrary console log statement inside of load state function. Switch over to the browser, refresh the page, and as we can see, that log load state has appeared. So that means now if we're going to modify our app state in any way, for example, by adding new activity, and then if we'll refresh the page, we're supposed to see our newly created activity. So it was persisted and successfully fetched from local storage. And the same will be true for timeline item objects. If we're going to modify any timeline item object and then refresh the page, we can see that the timeline item object state was also restored. So now let's just go back and remove all those temporary console log statements from all these functions. And at the end, I prefer to refactor this part of code. We can leverage ternary expression in here to make this code a little bit more concise. So if tab with our application will become active, which means visibility state property will be equal to visible. In this case, we're gonna call load state function to load the state from local storage. Otherwise, we should save the state to local storage before our app gets destroyed, meaning that our app is closed or tab with our application becomes inactive. So that looks good. Let's continue development in the next lesson. In this lesson, let's improve the logic which fetches current state of the application from local storage. But before that, as we can see when we start tracking the time, this time gets incremented by 2 minutes every second. We have previously made this change to simplify our testing, and now it's time to revert that change. So we have to open up the component responsible for rendering stopwatch, that is timeline stopwatch component. In the editor, let's open up this file, timeline stopwatch. Right here we can see that stopwatch logic was actually extracted into a separate composable function, useStopwatch. So let's open up the file with this composable function, and right here we can see temporary constant called temp, which currently stores amount of seconds into minutes. So we need to change this value in such a way that every second stopwatch time will be incremented by 1 second. So we have to use value 1 like this. And now we are ready to continue working on the functionality to load data from local storage. So in this file main.js, we have a function load state, which reads the state of the application from local storage, but now we also have to consider cases when local storage will not actually have any app state. And we can easily reproduce such situations. So in this function load, instead of returning app state, let's return an empty state. And right away we'll start getting some weird errors in the console. So here we need to write some additional checks to make sure that the state exists. In case with activity objects it's pretty easy, we just have to check if activities property exists on this state object. If so, we're going to assign red state to the reactive variable activities. Otherwise, if it doesn't exist, we're going to simply reassign default activities which are already stored in this reactive variable, like this. And as for these default activities, we generate them by using generateActivities functions, which generates 3 activity objects for testing. Later, once our application will be fully finished, we're not going to generate any default activities and let the user create them. So once again, let's check current state of our application in the browser, as we can see, we're still having an issue, but this time it is a different error related to timeline items resource. So we need to consider the following case. For example, let's assume that we have used this application a couple of days ago. So that state which was saved in the local storage last time we have used the application corresponds to the state of the completely different day which has already passed. And this means that the state which is stored inside of local storage is kind of updated because it doesn't correspond to today's date. So in this case, we're not supposed to load outdated state. So in here, let's write the following check. We're going to use the new function isToday, which we're about to define soon. This function is going to check if the date when we saved state of our application into local storage corresponds to a different day other than today. And by the way, we can easily check it by using property date on the state object, because anytime we save data into local storage, along with that, we are also saving the date when this data is being saved into this date property. So if the state stored in local storage corresponds to today's date, we're going to use this state. Otherwise, we're going to fall back to the default state, basically by reassigning timeline items variable to itself, like so. So moving on, and now we will create a couple of additional helper functions to simplify our further testing. So inside the time.js module, we'll create the function which is going to return the date object which corresponds to the current date, like this. In the same way, we're also going to create similar function, but for getting the date which corresponds to the tomorrow. So in here, we're just modifying the date of today by simply adding 1 to the date. And this way, we're getting tomorrow's date. And finally, we need to define another function, which is isToday, to check if the past date corresponds to the today's date. And we can easily do this check by simply comparing string representations of both of these dates. And if they are equal, that means that past date corresponds to today. And since all of these functions are gonna be used outside of this module, it's necessary to export them. Let's write an export keyword in front of every function. So let's go back to main.js and import the function isToday from the time module. Let's also revert those changes we have previously made to the load function inside storage.js, so it properly returns saved state from the local storage. And also before saving the data to the local storage, as a value for the date key, let's use our newly created function today, which returns current date, like so. And as always, before we can use this function, we have to import it first. So in the browser, we're still receiving an error, which is happening inside start timer function. So let's go back to the module time.js, scroll down, and in here, where we reset reactive variable current date by assigning object date, now we have to assign the date of today, which we can get by calling function today, like this. Alright, no more errors in the console. We can continue testing. So let's save the current state of our application to local storage. Let's open it up and see what date this state corresponds to. So today is November 11, which is the date stored under the date key right here. And now let's mock the function which returns current date, this function today. So we'll make this function to return date which corresponds to tomorrow. So back to the module time.js, and inside of function today, we'll add 1 to the current date in order to get the date of tomorrow. And after doing this, before loading the state of our application from local storage, inside this load state function, we're gonna do this check, and if the state stored in local storage does not correspond to today's date, we're not going to use the state from local storage, but instead we're going to fall back to the default state. And the default state is basically initial state of the application, where all timeline item objects do not store any tracked seconds, as well as they do not have any activities assigned to them. So after refreshing the page in the browser, as we can see, our app state does not show any tracked time, because the state which is currently used is a default state. Since when we were trying to load the state from the local storage, we have compared the date stored under the date key with today's date, and if those dates do not match, we're not going to use the state stored inside of local storage, but instead fall back to the initial state of the application, so that all timeline item objects will not have any tracked time. So let's go back to VS Code and revert that temporary change made to today function, where we were mocking tomorrow's date. And as a reminder, if the state stored inside local storage will be outdated, we're going to use default timeline item objects. These objects are generated by using generateTimelineItems function inside timeline_items module. And this function generates 24 of such objects, where each object corresponds to a particular hour in a day. And with that, let's finish this lesson. The link to the source code of this project will be in the video description. Currently, the main module of our application main.js contains quite a bit of logic, but it is generally considered a good practice to keep the main module clean. So I prefer to move these two functions, load state and save state, into a separate module, since they are related to synchronization of the app state with the local storage. So we're going to move these two functions into storage.js. And this way, our main module will only contain this function called load state in order to load the state from the local storage, as well as registration of this listener, because we need to detect when tab with our application will become active to load the state from local storage, or inactive to save the state into the local storage. So we're gonna leave this listener registration in this module along with app initialization. And now let's move these two functions, load state and save state, into storage.js. So we'll start with save state function. Let's cut it from here and move it into storage.js. So since this module already contains another save function, we're gonna have to combine these two save functions into one. If before we were passing the data that we need to store in the local storage as the parameter into save function, but now we're going to specify this data explicitly without passing it from outside. So in here, instead of destructuring the data, we're gonna specify directly the data we need to store, which is timeline items array as well as activities array. And now there is no need to pass any parameters into this save function. And by the way, we don't need to manually stringify current date object by using method toDateString before storing it in local storage. So let's remove this function call. So now we can safely remove the first function save state, since this is no longer used. And now let's move up and import all necessary data in this module. So since we are explicitly referencing array of timeline items as well as array of activities in this module in order to store both of these arrays in local storage, let's write down and import statements for both of these arrays in here. So this way we can clearly see what kind of data gets stored in the local storage by looking at this save state function. And now let's do similar refactoring to load state function. And now let's follow the same procedure to combine these two load state functions into one. I'm gonna move the implementation of the load function directly into load state function. So we don't need to call this load function anymore. Before proceeding, let's remove the implementation of the first load function. And in here, when we are getting the state from the local storage, since this state will be in the stringified form, let's call this variable serialized state. And later, when we're gonna parse this state to turn it into JavaScript object, we're gonna then save parsed state into the state variable, like so. So let's see what else we need to do in this module. Oh, by the way, isToday function has to be imported right here. And now we also have to export load state function, since we're gonna reference it from our main module. And now if we go back to main.js, we're gonna see several unused imports. So let's remove all of these unused imports and instead import only two functions, load state as well as save state, from the module storage. And as we can see, the main module is much cleaner now. It only loads the state of the application from local storage on the initial page load, and also it registers listener for the event visibility change to detect when tab with our app will be active or inactive in order to load state from local storage or save it back to local storage before actually browser tab with our application will be inactive. So now everything related to syncing the app state with the local storage is grouped into a separate module, storage.js, and in here we can easily see what kind of data we're loading from the local storage, as well as what data we are saving. Because now this whole logic is grouped in one module. Before finishing this lesson, let's see if after page refresh, our app state will be restored. So let's start tracking the time, and if after the page refresh this 4-second will still be displayed, this means that our app state was successfully restored from the local storage. As we can see, everything is working. In this lesson, we're gonna work on the following thing. So whenever we start tracking the time for a particular activity and then refresh the page while timer is still running, after page refresh, we see that the timer is actually stopped, but we need it to keep running if it was previously left in the running state. And since we have a bunch of such timers on one page, we need to add an additional property to timelineItem object to keep track of the state of the timer. So let's switch over to timelineItems module. In here we'll find the function which generates timelineItem objects. This is this generateTimelineItems function. So in here we'll add an additional property. Let's call it, for example, isActive. So anytime we will start tracking the time, this property isActive will become true, and once we stop the timer, it will become false. But in order for this change to take effect, we have to actually go to load state function, which is inside of storage.js, and emulate the situation when there is no state in the local storage, because otherwise the previous app state will be loaded where isActive property does not exist yet, and we will not see any changes. So temporarily in here, I'm gonna assign an empty state to the state constant so that the new timelineItem objects will be generated that will contain new isActive property. And if we'll take a look at the array of timelineItem objects inside Vue DevTools, in here we can see newly created property isActive, which is false by default. So now we can revert this temporary change inside of load state function, and we can proceed. So let's open up the component which renders timer. It is timeline stopwatch component. Anytime we click the button to start the timer, this function start gets executed. Let's open up the file where this function is defined. It is inside of this composable function stopwatch. And here we can see that when timer is started, is running reactive variable is assigned referenced to the timer. And when we stop the timer, this function stop is executed, an isRunning variable gets assigned value false. So based on this state variable, we can modify new property as active. So we have to watch for changes in this isRunning reactive variable. Let's go back to timeline stopwatch component, and the way we're gonna do it is by using function watch. The first argument will be that reactive variable we'd like to watch for. It is a running variable in this case. And as a second argument, this watch function accepts closure, which will be triggered anytime the first argument will change. So in here what we need to do is actually update current timeline item object. We can do so by calling update timeline item function. But in this case, we're gonna have to modify property isActive. So we will determine the value for this property based on the state variable of the timer called isRunning. So when this variable will be false, that means timer is stopped. Otherwise, it will contain a reference to the working timer. So we're gonna cast it to boolean before actually storing it inside isActive property. And just because a reference to the working timer will always be some non-zero value, this cast will always return true when the timer is running. So let's not forget an import watch function from the Vue package up here. And now to test it out, let's use console log statement inside of this closure and see what reactive variable isRunning will be equal to anytime we're gonna start or stop the timer. Let's switch over to the browser and try to start the timer. In this case, we see that isRunning variable equals to true. And when we will stop the timer, this variable will be equal to false. That's exactly what we need. So let's go back to the editor, remove the temporary console log statement, and now based on the value of isActive property, we need to decide when to start the timer automatically. So I'm going to use hook onMounted to run some logic when the component is created. And here let's just check value of the property isActive, and if this property will be true, in this case we need to start the timer. We can do so by calling function called start, like this. And since we are always saving the app state to the local storage before app gets closed, if we have previously left the timer running, this property isActive will be true. And after page refresh, this timeline stopwatch component will be created, which means this unmounted hook will be called. And since this property isActive will be true, we're gonna start the timer automatically. And now let's test this behavior. I'm gonna leave the timer running before refreshing the page. And this time, as we can see after page refresh, timer is started automatically. So we have successfully loaded the last state of the timer from the local storage and decide whether we should automatically start the timer or not. Let's continue working on our project in the next lesson. There is one special case related to the stopwatch that we need to handle separately, and that is when we start measuring time for a particular activity, we can see that this time will be changing on the activities page as well as on the progress page. But the thing is that if we refresh the page, while being on a different page other than timeline, we will see that the time is no longer updating. And this is because we are checking that one of our timeline item objects is active and start the timer for the timeline item object only on the timeline page. But in this case, timeline page is never created because we have just refreshed the page while being on a different page. So to handle this case and always start the timer regardless of the page where we open up our application, we have to register global timer that will be automatically started every time we open our application. So we can implement the logic to handle global timer inside timeline items module, since this logic is related to timeline item resource. Right here let's declare a variable to hold the reference to our timer let's call this variable timeline item timer. Initial value will be null. And down here, we're going to create two functions that are going to manage our global timer. First function is going to start global timer, and the second function will be used to stop the global timer. Let's call this function stop timeline item timer, like this. But of course, we should start the timer only if we have active timeline item object. In other words, if we have previously left our application while our timer was running. So let's find an active timeline item by doing the following. We're going to iterate over timeline items array, and if property is active will be true for one of timeline item objects. That means active timeline item exists, and we're gonna store a reference to this object in active timeline item constant. And as a reminder, we have added isActive property to every timeline item object in one of the previous lessons. So now we have to register the function that will be executed every second, because we have to update the time every second. So right here, I'm going to call setInterval function to register global timer, which is going to update active timeline item object. And specifically, we have to update property called activity seconds. There is a function that we have created before called update timeline item, which accepts timeline item object as the first parameter that we have to update, and as a second parameter, it accepts array of overwritten fields. So we're going to update activity seconds property by incrementing it by 1 every second, like so. Also, let's specify that we'd like to run this callback every second. I'm gonna use milliseconds in a second constant. And also, to achieve better separation of concerns, we can extract this part of code into a separate function. Let's call this function find active timeline item, which we're going to declare right here. Let's paste that line in here and return the result. And as for another function, stop timeline item timer, the implementation will be pretty simple, since the only thing we have to do in here is to clear our global timer, which we can do by calling clearInterval function. And as a first parameter, we need to pass the reference to that timer we would like to stop. Of course, these functions are not going to do anything unless we call them. So we need to start the global timer every time we will start our application. That means we can call the function start timeline item timer inside of our main module. So right here, I'm going to call that function, which should be imported from timeline items module. So now let's check the result. What happens if I will load the application, and right away we're seeing an error in the console saying that cannot access property activity seconds. And that is because there is a possibility that we will not have any active timeline item objects. And this can happen if we'll close our application while none of our timers is in a running state. So to avoid this error before actually starting the global timer, we firstly have to check if we have at least one active timeline item. So let's call the function findActiveTimelineItem in here, or we can do it in a different way. Firstly, let's create a constant active timeline item and store a reference to the active timeline item in this constant, like this. So let's add an import for this function right here, and then to tell which timeline item object the timer should be started, we're going to pass this object as the first parameter to start timeline item timer function. And then going back to the implementation of this function, instead of actually calling the function to find active timeline item, we're going to accept active timeline item object as the first parameter. And before checking everything in the browser, let's export findActiveTimelineItem function, because we're using it inside main.js. So it's finally time to check it out. Let's start tracking the time for some activity, and then make sure this time will be increasing on the progress page. But what's most important is that this time should be updating after page refresh. And this is exactly what is happening. As we can see, timer keeps running. And this is due to that global timer that we have started right before our application was initialized. But now we have a different problem. So if I'm gonna go back to timeline page and try to stop this timer, we can see that the time will still be increasing. And this is because every timeline stopwatch component has its own timer, which gets initialized when the timeline page is opened. But the thing is that we never stopped that previously started global timer. And currently we have two timers running at the same time. The first one we can stop by clicking on the stop button, but another timer, which is global, we cannot stop because we never call the function stop timeline item timer. So let's determine where we need to call that function to stop the global timer. And probably the best place to do it will be inside of the timeline page component, because we know that this page contains individual timeline stopwatch components, and each of those components has its own timer. So those components will handle stopping and starting timer themselves. But right before that, when the timeline page component gets initialized, let's call the function stop timeline item timer to stop the global timer before each of those individual timer components will be created. And in this case, we don't need to additionally check if we have active global timer, because anyway, if we're gonna call function clear interval and pass timer which is not running, clear interval function is not gonna cause any error. And just to better see when our global timer will be started and stopped, I'm going to add a couple of console log statements inside of both of these functions, in here as well as inside of start timeline item timer function. So in the browser, once I'm gonna start tracking the time for a particular activity, on the progress page, let's make sure this time will be increasing, and right after I refresh the page, I will see one log entry, which means the global timer was started. And that is why we're still seeing that the time for coding activity is updating. And this global timer should be stopped once I'm gonna switch to timeline page. And there we go, we see another log entry, which means that the global timer was stopped. But still, stopwatch time is increasing, because, as I said before, each of these timeline stopwatch components has its own logic to handle the timer that belongs to it. And we can continue manage this timer by stopping and stopping it. At the end, let's go back to the editor and remove those two console log statements. The link to the source code of this project, as always, will be in the video description. Let's review another edge case, also related to stopwatch component. So here is the problem. If I'm gonna start tracking the time for a particular activity, and then we'll close the tab with an application, and after some period of time I'll come back to the application again, the time that was passed while our application was inactive will not be added to the total amount of tracked time. So basically that passed time will be gone. And here is an example. If I'll start tracking the time for coding activity, and let's say I'll close this application when the stopwatch reaches 5 seconds, and then I'll wait for about 5 seconds while being on another page, and then come back to our application. As we can see, the stopwatch starts counting from the 5 seconds, so those additional 5 seconds that have passed while we were being on a different page are gone. So let's figure out the way how we can fix it and actually include idle time to the total amount of tracked seconds. Let's go inside storage.js, and in this function load state, firstly I'm going to extract the date when our application was last active into the constant last active at. And by the way, let's also rename this key date on last active at, because this key stores the date when our application was last active. So we're gonna have to rename this key right before we save the state of our application to local storage right here. And now let's get back to the function load state. So right here I'm going to pass this date last active at into isToDate function to determine whether our application was last active today. And before actually working with timeline item resource, I'll firstly assign all activity objects read from the local storage to activities reactive variable. And after that, we can start handling timeline items objects. So in order to add those idle seconds that have passed since our application was last active up until the next time when our application will be opened, we're going to use function sync_idle_seconds that we are going to define next. So in here, let's declare this function, which is going to receive two parameters, timeline items array, as well as the date last active at. And once again, this is the date of the last time our application was active. The first thing we're going to do in this function is actually find active timeline item object. Let's call method find on this array to find active timeline item by checking the key is active, and if one of these keys will be true, that means that we have found active timeline item. Because there is no point to add those idle seconds if none of our stopwatches were running before we have closed the application. But if we were able to find the active timeline item, here I'm gonna use if conditional, and inside we have to add idle seconds to the total amount of tracked seconds that were tracked right before we have closed the application. So we have to modify property activity seconds of active timeline item object by simply adding those past seconds. And the way we can do this is basically by subtracting the date of the last time our application was active from current date. And eventually this expression will return us amount of milliseconds passed since we have last time used the application. And then to turn this amount of milliseconds into seconds, we have to divide this value by amount of milliseconds in 1 second. And this value is stored in the constant milliseconds in second. So I'm going to divide the result by milliseconds in second constant, like so. And this way, an active timeline item object will be modified and will contain those amount of seconds passed since our application was last active. And then the timeline items array with the modified timeline item object will be assigned to timeline items reactive variable. And just to see if our calculations are correct, I'm going to print out the result of this whole expression in a console. And now let's check it out. But firstly, let's make sure if our latest change to the state of our application, which is renaming the key date on last active at, took effect. And indeed, we can see this key with the new name. So now let's do the same testing steps that we have done at the beginning of this lesson, which is tracking the time for a particular activity. And once stopwatch reaches 5 seconds, I'm going to switch to a different page, wait for about 5 seconds, and then come back to our application. And this time we're supposed to see that those 5 seconds should be added to the total amount of tracked seconds that were present before we quit the application. In this case, we're seeing 11 seconds because I was on a different page for 6.6 seconds, as we can see. And this amount of seconds has been added to the total amount of tracked seconds, just like we want. So now let's go back to the editor and remove this temporary console log statement. The link to the source code of this application, as always, will be in the video description. So now we're going to handle another case, also related to stopwatches. If we start this stopwatch and then close the application, and if we'll keep the application closed for more than 1 hour, we should keep only those idle seconds until the hour when the stopwatch was initially started. In other words, all these stopwatches should count no more than 1 hour. If I'm going to start tracking the time when the current hour equals to 0, and then I'm going to rewind the time 1 hour forward, and let's see what is going to happen. So let's start tracking the time for the coding activity. Then let's go back to the editor and modify the current date. Instead of the midnight, let's use first hour. In the browser, we'll see that the current hour is now the first hour, but the previous stopwatch shows the time that is more than 1 hour. But we have to prevent this behavior so that every stopwatch will count only up to 1 hour. So to fix this, we have to modify the code inside storage.js. In here, we are syncing idle seconds with timeline item objects, and specifically, we calculate the difference between two dates, current date as well as that date when our application was last active. But besides doing that, we also have to determine if our application was closed for more than 1 hour. So we'll have to do a couple more checks. Actually, one more check. Let's start. I'm going to create another function and call this function calculate idle seconds, which is going to accept one parameter, which is the date when our application was last active. And then instead of doing this kind of calculation, we'll call our function calculate idle seconds, passing last active at date. Let's move that calculation inside this function calculate idle seconds. First of all, we'll find the difference between two dates, the current date as well as the date when our application was last active. This way, we're gonna get amount of seconds passed since the moment we have closed the application. Here will be an additional check to determine whether our application was inactive for more than 1 hour, but if not, we'll basically do what we had been doing before by simply returning this value, but before this has to be converted to seconds. So let's divide this value by milliseconds in second constant like this. So with this logic, our application is going to function correctly only in those cases if we start measuring time for a particular activity, then close the application and open the application again if current hour wasn't passed yet. So now let's start handling the case when we'll keep our application closed for more than 1 hour. So to determine if we kept it closed for more than 1 hour, let's use the following check. Firstly, let's get an hour of last active at date and compare this hour with the current hour. We can get the current date by calling function today and call function getHours to get the current hour of this date. And so if these two hours are not equal, that means we should calculate the difference not between current date and the date when our application was last active, but we actually have to find the date which corresponds to the end of an hour when we started tracking the time for an activity. We're going to use a separate function to calculate end of hour. Let's call it get end of idle hour. This function is going to accept last active at, and then once we find this date, we'll subtract the date when we have closed the application last time, which is last active at date. And now the only thing left to do is actually implement get end of idle hour function. Right here, let's declare this function. It will take one parameter last active at. So here let's declare a new constant that is going to store the date we're about to find, which is end of the hour when we start tracking the time for an activity. Firstly, we'll create this date based on last active at date, like so. And now we're going to rewind this date forward by 1 hour. So we can do it in this way. Firstly, let's call method setTime, which accepts amount of milliseconds. Let's get amount of milliseconds of end of idle hour date first. And to this date, we have to add amount of milliseconds in 1 hour, which we can get by multiplying two constants, seconds in hour and milliseconds in second, like this. Next, we'll reset amount of minutes, amount of seconds, as well as amount of milliseconds for this date. And this way we'll find the date that corresponds to the end hour when we start tracking the time for a particular activity. And eventually we'll return this date. before returning, let's just print out this value to the console and see what date we'll get. So let's test it out. I'll start tracking the time for the coding activity, while the current hour corresponds to midnight hour. And then if I'll rewind the current time 1 hour forward, we'll actually see that the current time is now 1 AM. But take a look at the time that the first stopwatch shows. Now it doesn't exceed 1 hour. This is exactly what we were trying to achieve. Even though our application was closed for more than 1 hour, still, the first stopwatch doesn't show amount of seconds that exceeds 1 hour. And also, as we can see in the console, that date that corresponds to the end of hour, when we start tracking the time for the coding activity, is actually 1 AM, because we started tracking the time for coding activity when the current hour was midnight hour. So everything is working fine. And also, as you may remember in one of the previous lessons, we have increased the speed of timeline indicator by simply shifting it down every second to the time that corresponds to 60 seconds. But we actually have to shift it down every second by the time that corresponds to 1 second. So there is no need to multiply milliseconds in second by seconds in minute constant anymore. So let's remove this constant from here. And while we are inside time.js module, let's scroll up, remove unused constant. And also there is no need to modify the current date by mutating amount of hours. So we can comment out this line for now. And now our timeline indicator will start moving down from the current hour. Let's also remove that console log statement inside storage.js and finish this lesson. Link to the source code of this project will be in the video description. In this lesson, we're not gonna implement any new functionality, but instead, let's focus on the refactoring. So let's start cleaning up code from storage.js module. In here, I prefer to extract this function getEndOfIdleHour and move it into more appropriate module for this function. And since this function works with time, it makes sense to move this function into time.js module. So let's cut this function from here, open up time.js. Right here, let's place that function and export it right away. And we can also make this function more generic, because inside this function we can see a couple of pretty specific names, such as EndOfIdleHour, as well as lastActiveAt. So we'll make this function to work with any kind of date. So let's rename this param on just date. And of course, this function should know about idle concept. Let's rename this constant EndOfIdleHour on EndOfHour. Then we have to import seconds in our constant in this file. And also let's get rid of idle word from the name of this function. And now we can go back to storage.js and use this function. So let's replace this function with a new name, EndOfHour. And also don't forget to import this function. And now let's just rewrite this whole logic in a different form. So we're going to use ternary expression, and based on the following condition, we're going to return different results. So if this condition will be true, we're going to use the following expression to calculate the result. Otherwise, we're going to use this one. And also please note that we are not changing the logic in any way. The logic will remain the same, we're just trying to make the code more readable and concise. Please also note that at the end of this implementation, we're dividing the result by milliseconds in a second constant, and this way we are converting amount of seconds in milliseconds. So the same thing we'll have to do in our new implementation. And this operation of conversion is actually a pretty good candidate to be extracted into its own function. So let's go back to time.js. In here, let's declare a new function, which is going to convert milliseconds into seconds. It will accept one parameter, amount of milliseconds we're about to convert. And right here, let's divide amount of milliseconds by milliseconds in second constant to get amount of seconds. Sometimes we're gonna get decimal value, so to round this result, let's use method round on the mass object, like so. And now we can leverage this function and wrap these two expressions into function 2 seconds, like this. And this way the final result will be converted to seconds. And also to avoid negation in this condition, we can use equality operator and simply swap two parts of ternary expression. So now the old implementation can be removed. And also let's scroll to the very top of this file. Here we'll see that two imports are no longer used. Therefore, let's remove them. So that's that. Let's move on to the different refactoring. Back to the file time.js. Right here we have this variable timer, which stores a reference to the global timer, which runs every second and updates a reactive variable that stores current date. So let's assign this variable a little more descriptive name. For example, current date timer. And also to be consistent, we'll rename these two functions as well. To start current date timer and to stop it. But since these two functions are called somewhere else, let's find that place. They are called inside the timeline component and rename them appropriately. Start current date timer and stop current date timer. Let's also not forget to rename corresponding imports right here. Let's continue. On the activities page of our application, we can see three default activities. They are generated at the beginning, but since now we no longer need these testing activities, we can remove them. So inside of activities.js module, there is a function called generate activities, which generates array of default activities. So we're going to use an empty array instead to have an empty list of activities at the beginning. This way, generate activities function is no longer used. Let's remove this function, as well as a couple of unused imports at the top of this file. There is also some commented code inside timelineitems.js module. So let's open up this module and remove all these comments. Let's also scroll to the top. Here we can see another comment. Let's remove this. And if we'll open up activities page again, we still can see those three default activities. That is because previous application state was restored from the local storage that still contains those default activities. But if now I'll remove these activities manually and refresh the page again, the state will be updated and we will no longer see those activities. The list will be empty. And right before we finish this lesson, I prefer to add hover state to now items. So when we hover over on these items, I prefer to dim the background a bit. We should do this change inside of corresponding component responsible for rendering now item. There is now item component. Right here we see classes computed property, which stores all classes assigned to the root element of this component. So instead of just assigning bg_gray200 class conditionally based on the following condition, we're going to use same condition and still assign this class if the condition will match. But if it will not match, we're going to use another class, which is going to add slightly gray background color when hovering over now item. Let's get rid of the following object, switch over to the browser, and as we can see, when I'll hover over now items, background color changes on light gray. But only for inactive now items. For the active one, it will remain the same. We will continue working on the project in the next lesson. At the moment, just because we are managing two separate timers to control the state of the stopwatch, one timer is global and another one is local, which belongs to any of these stopwatch components. And due to that reason, the code seems a lot more confusing than it could have been. Plus, we have an issue with our current implementation, so let's start tracking the time for a particular activity. As we can see on the progress page, this time is increasing, but what if we're gonna switch tabs, and then, after some time, we'll come back to the tab where our application In this case, we're going to see that this time is no longer increasing. So stopwatch stops automatically whenever we switch tabs, or in other words, when tab with our application becomes inactive, and stopwatch will continue counting the time if we'll switch to timeline page, because once we're on this page, local stopwatches get initialized. So in this lesson, I prefer to do a global refactoring of the logic that belongs to controlling the state of stopwatches. So in the timeline items module, we have a couple of functions such as start timeline item timer as well as stop timeline item timer to manage the state of the global timer. But besides that, every timeline stopwatch component has its own local state, which is encapsulated inside this composable function useStopwatch. Let's open up this function, and here we can see functions start and stop that manage local state of the stopwatch. As we can see, every second reactive variable seconds gets updated, and we are watching for changes in this variable inside timeline stopwatch component, and every time when this variable is updated, we are updating timeline item object by calling this function update timeline item. In this case, we are updating the property activity seconds of timeline item object every second as our stopwatch continues running, and also we are watching for changes in its running reactive variable, and this variable is updated only when we either start or stop stopwatch, because in this case we have to update another property of timeline item object, which is active, since every timeline item object which has stopwatch running is considered to be active, and vice versa. So now let's start refactoring the code to eventually get rid of the local stopwatches. So let's begin with a function which starts timeline item timer. In here, I'm going to rename this parameter on just timeline item. And before we actually start a global timer, we have to update isActive property of timeline item object, just like we are doing in here when we were watching for changes in its running reactive variable. So when the global timeline item timer will be started, that means that isActive property should be true. And of course, we do not have access to the props object in this global function. So to determine which timeline item we have to update, instead of referencing props object, we're simply going to forward timeline item object that we have received as a parameter in this function, like this. And now let's switch to a different function stop, to stop the stopwatch. So right here, in order to stop the stopwatch, we are firstly clearing interval to prevent previously started timer from running any longer. And besides that, we also have to assign value false to reactive variable isRunning. But the thing is that this reactive variable isRunning is the state of the local stopwatch, but we are trying to remove all the logic related to local stopwatches, because eventually what we are trying to achieve is actually have only one state variable that will be the state of a global timer, and such variable in our case is this timeline item timer variable. So let's turn this variable into reactive variable by calling function ref. On the initial page load, stopwatch is not started, so we'll use value false as an initial value in here. And everywhere we were using timeline item timer variable before, now since it's a reactive variable, we'll have to use property value like this when we assign reference to the timer, as well as when we clear this timer right here. As we can see before, we were also manually assigning value false to variable isRunning, so let's do the same for our global state. Let's assign value false to timeline item timer variable, like so. And besides doing that, we also have to update property isActive of that timeline item object we are stopping the stopwatch for. So right here we have to call update timeline item and update property isActive by assigning value false, since we are stopping the timer in this case. And in addition to these two functions for starting and stopping the timer, we also had another action, which is resetting the time of the timer. So we have to create similar function, but for the global timer. Right here I'm going to export a new function with the name resetTimelineItemTimer, which is about to receive one parameter TimelineItemObject. And resetting the timer basically means assigning value 0 to property activity seconds of TimelineItemObject. So right here let's also call updateTimelineItem function and specify in this case that we would like to update only one property, which is activity seconds, by assigning value 0. And just because along with resetting the time for a stopwatch, we also had to stop the stopwatch. So right here, let's call the function, which is going to stop our stopwatch, stop TimelineItemTimer, and pass that TimelineItem object, stopwatch, of which we are about to stop. The next thing we're going to do is move this watchEffect function call into global TimelineItems module. And what this watchEffect was doing before, it was actually watching for time updates and whenever current hour was changing, and at the same time if we had stopwatch running, in that case we had to automatically stop the stopwatch, and that is why we're calling function stop right here. But because currently we are in the global scope and we don't have access to the props object, we need to somehow find out which TimelineItem object is currently active. In other words, stopwatch of which TimelineItem object is running. We can easily find out which TimelineItem object is currently active. So for that, I'm going to create new computed property with the name ActivityTimelineItem. And what this property is going to do is basically going to iterate over array of TimelineItem objects and look for that TimelineItem where isActive property will be true. In this way, we will find active TimelineItem object. So now inside this conditional, let's reference our active TimelineItem computed property, and before checking if hour of this TimelineItem object does not equal to current hour, we also have to make sure that we even have active TimelineItem. So before that, I'm going to add an additional check. So we no longer need to check the value of its running reactive variable. Let's get rid of it from here. So in order to stop the timer, we have to reference function stopTimelineItemTimer instead of this function stop. And to tell this function which stopwatch we have to stop, we'll simply pass active TimelineItem object into this function like so. And this way there is a bunch of code that can be removed from timeline stopwatch component. Let's open up this component and remove unnecessary code, such as this function onMounted, this watchEffect, as well as this watcher. Also we had to conditionally determine which button to show, either button to stop the stopwatch or start the stopwatch. But if before we were using isRunning local reactive variable, this time, since we're going to control state of the stopwatch globally, we have to reference different variable, which is TimelineItemTimer. And since we can only show the pause button for the TimelineItem which corresponds to the current hour, let's add additional check in here and see if hour of current TimelineItem object equals to the current hour. That means we can show pause button. Let's keep going, and regarding this function start, now it is called startTimelineItemTimer. So let's call this function and specify which TimelineItem object we're going to start stopwatch for. And basically the same thing should be done to stop function. Let's replace this function with stopTimelineItemTimer and pass first parameter, which is TimelineItem object we are about to stop the timer for. And eventually we end up with only one function reset that we are still receiving from composable function stopwatch. So let's change function reset and use new function resetTimelineItemTimer. And as always, we need to pass which timeline item object we are resetting the time for. So at the end, stopwatch composable function is no longer needed. So we can open up the file with this composable, which is stopwatch.js, and simply remove it. There are a bunch of unused imports in this component. Let's remove each of them. And instead we should import a bunch of things from timeline item module. Mainly those are the functions that allow us to manage state of the global stopwatch. So let's just import them one by one in here. First of all, it is a function to start global timer, then function to stop it. Also we need a function to reset the time of the stopwatch. And also in this component we are referring to timeline item timer variable, which stores reference to the global timer. By the way, there is no need to assign props object to the constant props, since we're not going to reference any props in the script tag. But as for referencing them inside the template, we don't need to explicitly reference props object, so we can remove this assignment as well as all those mentions of a props object from the template. Now let's go back to timeline items module, and since I prefer to group all variable declarations as well as computed property declarations in one place, let's move this computed property closer to all reactive variables right here. And there is also function with a name findActiveTimelineItem, which is pretty similar to the computed property ActiveTimelineItem. It is doing the same thing, so there is no need to keep this function anymore. Let's remove it, and whenever we were referencing this function, let's refactor this part of code by simply using ActiveTimelineItem computed property instead. So let's import this property from timeline items module, and additionally, whenever we are referencing this ActiveTimelineItem variable, we have to get the underlying value of this property by referencing property value like this. And also in here, when we are passing ActiveTimelineItem object to start timeline item timer function. And as you may remember before, whenever we would open up timeline page, we had to always stop global timeline item timer. Otherwise, after local timers will be initialized, we'll end up with two timers running at the same time, which we don't want. But now, since we completely got rid of local timers, there is no need to stop global timeline item timer, since we're always going to have only one timeline item timer running at the same time. Let's remove this function call as well as its import. And by the way, we also have to export additional variable from timeline items module, which is timeline item timer variable. So let's add an export keyword in here. And we can also make this variable a constant, since we're not going to override the value in this variable, because we are only going to modify value property of this object. So now, after doing so many changes, we have to make sure that our application still functions correctly. Let's start tracking the time, then stop this timer to see if we still can do it. Then let's start it again and reset the time of this stopwatch. So far everything is working. Let's see if stopwatch will still be running after page refresh. This is also working. And now let's assign activity to this timeline item object and make sure that the time on the progress page will be increasing. As we can see, it works. On the activities page, this time should be decreasing. And if we're gonna refresh the page, while not being on the timeline page, this time will still be increasing. But as for that problem that we have faced at the beginning of this lesson, whenever I would open up a different tab and then come back to the tab with our application, in this case, we can see that the timer was stopped. And since the current lesson has gotten quite long, let's work on this problem in the next one. Link to the source code of this project will be in the video description. Before we're gonna get to fixing that bug that we found at the end of the previous lesson, I prefer to move some part of the logic from timeline items module into the new module, because as we can see in here, this timeline item timer constant, as well as the following functions start timeline item timer, stop timeline item timer, and reset timeline item timer, they all are meant to manage the state of the global timeline item timer. So let's just cut all these functions from here and create new module with the name timeline item timer. In here I'm gonna paste all that code, and now I'm gonna quickly go through this file and import all necessary variables and functions. And let's just quickly switch back to timeline items module, and from here remove unnecessary imports. And now we just need to fix a couple of imports. Firstly, let's go to timeline stopwatch component. In here we're going to import start, stop, and reset functions from timeline item timer module instead of timeline items. And the same thing we have to do inside main.js. The start timeline item timer function has to be imported from timeline item timer module, like so. And actually I forgot to import one more thing inside timeline item timer module, that is this reactive variable now. Let's add an import for this constant. So in here we can see right away the state of the global timeline item timer, as well as all the actions that can be performed with this timer, such as starting, stopping, and resetting. So before finishing this lesson, let's just open up our application and test a couple of things. Firstly, let's start tracking the time and make sure that the time will be increasing on the progress page. Now let's also stop the timer and reset the time. As we can see, everything is functioning properly. Let's continue our development in the next lesson. In this lesson, we will finally get to fixing that bug that we have found in one of the previous lessons related to stopwatch. So if I'll start tracking the time and then switch to a different tab, making our application inactive, and then if I'll try to get back to our application, as we can see, the stopwatch was automatically stopped, even though we have left it in the running state before switching to a different tab. So let's see what's going on in here. I'm gonna switch over to the editor and open up the main module of the application, which is main.js. So right here we can see that right before our application is loaded, we're calling this function loadState in order to load the state of our application from the local storage. And then we have this if conditional, which checks if we have previously left one of the stopwatches in the running state, we should automatically start it. And then we are registering listener to listen for when the tab with our application will be either active or inactive. But as we can see, that function start timeline item timer that is supposed to automatically start the timer is never called again, regardless of how many times we're gonna make tab with our application active or inactive. And that is why when we are coming back to our application from a different tab, timer is not automatically started. So we're gonna rewrite some of the logic in this file a little bit differently. So let's just use the new function sync_state, which we're about to create soon, and this function will be responsible to load as well as to save the state of our application to local storage. And whether to load or to save the state, it will decide based on the first parameter we're about to pass into this function. The first parameter will get the value of the following expression. So when tab with our application will be active, this parameter will turn true, otherwise false. And now let's open up storage.js and declare the new function. So I'm going to export the new function with the name sync_state, which is going to receive one parameter, let's call it should load, with a default value of true. And then based on this parameter, we will decide whether to load the state or to save it by using the following ternary expression, like so. But besides loading or saving, we also have to decide when we should start timeline item timer or stop it. So in here I'm gonna check if we currently have active timeline item. In other words, if we have previously left our application when one of our timers was running. If this is true, then we'll use another ternary expression based on shouldLoad variable as well. That means if we are currently loading the state and at the same time we have active timeline item, we're supposed to start timeline item timer. So let's call the function start timeline item timer. Otherwise, we have to stop it. Here we're calling the function stop timeline item timer, and both of these functions have to know for which timeline item we are starting or stopping the timer. So let's pass active timeline item as the first parameter into both of these functions. Now let's import all necessary parts in this module. Let's go back to main.js and import newly created function sync_state. So now we no longer need this conditional. Let's remove this part of code. And let's just go over all this logic once again. So this listener will be triggered whenever tab with our application will become either active or inactive. And just to let sync_state function know whether tab with our application has become active or inactive, we're passing the result of this expression as the first parameter. And in here, based on that expression, if tab with our application has become active, we're loading the state from the local storage, and in addition, starting the timer. In case we had stopwatch running before making the tab with our application inactive. And in another scenario, when parameter shouldLoad will be false, that means tab with our application has become inactive, we're saving the state of our application to local storage instead of loading it, and then also stopping the timeline item timer in case we had one running. So the main part of the functionality is ready. Now I'm gonna go back to main.js and remove all unused imports from here. And now just to simplify our testing, let's just add some console log statements into a few functions. I'm gonna add one inside of save state as well as load state. And also let's just add a couple more into start timeline item timer function as well as stop timeline item timer. So now let's see what logs we're gonna see in the console when we refresh our application. So here we have two logs. Firstly, before refreshing the application, the state was saved into the local storage, and right after we pressed refresh button, we have loaded the state, which is indicated by the following load state statement. And if I'll manually start the timer, sure enough we're gonna see the log start timeline item timer. And if we'll try to refresh the page while stopwatch is running, firstly we'll see the log from stop timeline item timer function because we had to stop the timer before refreshing the page. And after our application is loaded back again, we're kind of resuming all previously saved state as well as resuming state of the timer because we have to start this timer automatically. So that means that anytime we're gonna make tab with our application inactive or close the application completely, next time tab with an application becomes active again or it is opened again, our stopwatch should start automatically. Let's make sure. I'm gonna start stopwatch and then switch over to a different tab. Let's switch back to the tab with our application again, and this time we see that the stopwatch was started automatically. So everything is working as expected. Let's just go back to the editor and remove all previously added console log statements from all these functions. Link to source code of this application will be in the video description. At the moment, whenever we assign activities to timeline items, as well as start tracking time for certain activities, all this current state of our application will be removed if we're gonna open up application another day, because we are only storing state of our application until the end of the day. but it actually makes sense to reset only tracked time, so we'll start new day when no time is tracked. And as for assigned activities, it doesn't make sense to make user to always select activities for some hours every day, because he can pre-select some activities for some hours and use this selection every day. So now if we're going to mock the situation when we will open up application tomorrow by using function tomorrow instead of today, this way when we open up application, the state will be no longer valid since we have opened application tomorrow by mocking that date. And also we are seeing that none of our data, including selected activities as well as tracked seconds, are not saved. So now we're going to implement such behavior that pre-selected activities will be persisted no matter which day we're gonna open up the application, but tracked seconds will be always reset on the new day. First of all, let's find that function which is responsible for loading the state from the local storage. In this function, we're gonna rewrite this logic which assigns timeline items read from local storage to timeline items reactive variable. Firstly, I'm going to rewrite this logic in a different way by using full conditional expression. So far I haven't written anything new, but just rewrote existing code in a different way. But in this second else block, we need to write an extra logic by resetting state of timeline item objects. And to do this, we're going to create new function called reset timeline items, passing timeline items array read from local storage. And this function can decide which data should be reset. So let's quickly write declaration for this function reset timeline items. Inside timeline items module, it is going to accept array of timeline items, and in here we're basically going to iterate over this array of timeline item objects by using method map. We will reset only certain properties instead of resetting everything. So let's destructure all existing data of this timeline item object and then reset a couple of properties such as tracked activities that are stored inside activity seconds property. We'll assign value 0, and also we're going to reset isActive property, because after we reset timeline items, none of the stopwatches should be active. I'm not going to stop at this logic in here, because this was implemented and explained in details in the previous lessons. So here we're just adding new function reset timeline items to be able to reset tracked time instead of resetting assigned activities to timeline item objects. And by the way, we're going to call reset timeline items function only when we open up application another day, not at the same day when we last had this application open, which we can ensure by calling isToday function with negation. And now let's see what is going to happen in the browser if I'll assign a couple of activities to different hours and also track a couple of seconds. And if we'll emulate the situation of opening up application tomorrow once again, as we can see, all the data was reset, not only tracked seconds. Actually, when we selected activities and then opened up application tomorrow, so to say, by mocking current date, our selection has been read from local storage, but we're not actually assigning timeline item data read from local storage to timeline items reactive variable. So before checking this condition, we have to actually assign read timeline item data to timeline items reactive variable. And in case this state will not exist, we're gonna fall back to default timeline item objects generated automatically like this. And these default timeline item objects do not have any activities assigned, as well as any time tracked. So now our selection should be persisted. Let's do it one more time. Firstly, let's revert the date back to today, and then modify the state of our application by assigning a couple of activities, and also track a couple of seconds for one activity. And this time, if we're going to mock the current date by specifying tomorrow in here and open up application again, this time, as we can see, activities were persisted, but not the time. All tracked time was reset. So this is exactly what we were trying to achieve. Alright, now let's revert that code that was mocking tomorrow's date. And at this point we're good to finish this lesson. Let's continue development in the next one. If we will take a look at the implementation of the load state function, it feels like this function is doing too many things. Actually, we can split the whole logic of this function by 3 parts. First of all, we're loading the state of the application from local storage. On the next step, we're initializing reactive variable activities with the data received from local storage. And the remaining part of this function is also doing initialization, but of timeline items reactive variable. So we can clearly see 3 different responsibilities, so to say. So now let's make it more obvious what is going on in this function by extracting some parts into its own functions. So the 3 things this function is doing is loading the state from local storage, initializing activities, and initializing timeline items. And now let's start from the first step. I'm going to declare a new function, load from local storage, and also declare new functions to initialize activities as well as initialize timeline items. And both of these functions are going to receive the state as the first parameter. Let's start with the first function. Down here, let's create this function. And then I'll take those 2 lines from the load state function and put them into this function. And at the same time, we can also try to inline serialized state variable. So instead of creating new variable, let's directly use the result of this expression and pass it to parse function. But in case there won't be any state inside the local storage, this expression will result to null. So in this case, to avoid any errors, we're gonna fall back to an empty object like this. Because if we're going to pass null to parse function, it is going to cause an exception. And this way we can get rid of this variable serialized state. And just because this function is a private one, it is not used anywhere but inside the same module. We don't need to export it. So the first step is done. Now let's switch over to the second one. Let's create function initialize activities inside activities module. I'm also going to cut implementation for this function, that is this line of assignment to activities reactive variable. And now inside activities module, right here, we're going to create the function initialize activities, which will get the state. And inside we can do all necessary actions to properly initialize activities reactive variable. Just in case there won't be any saved state inside local storage, we will fall back to an empty array. So next we're going to do pretty much the same steps, but for initialize timeline items function. From here, let's cut this implementation, go to timeline items module, and right here, export new function with the name initialize timeline items, which is also going to take the state. And just because this function references sync_idle_seconds function, which is defined inside storage module, we also have to move this function inside timeline items module. As we can see, this function calls another function calculate idle seconds. So let's take these 2 functions, cut them from here and move inside timeline items module. And now we're going to import all necessary parts that are used in both of these functions. Next, let's scroll up to the declaration of timeline items reactive variable, and instead of assigning default timeline item objects to this variable, we're gonna initialize this variable with an empty array first, and then, while we are calling initializeTimelineItems function, right here, in case there will not be any saved state inside local storage, we're going to generate default set of TimelineItems objects by calling generateTimelineItems function like this. So let's take a look at the loadState function once again. Firstly, let's remove all the comments. And as we can see, this function is much more clear right now. It is clear to see that this function is firstly loading the state from local storage and then initializes a couple of resources. And the code responsible for initialization of each of these resources is actually contained within corresponding modules, activities, and timeline items. And by the way, both functions, loadState as well as saveState, are not used outside of this module. Let's make them private by removing export keyword. Just a side note, loadState and saveState functions are only used in the universal function sync_state. As we can see, there are a couple of imports that are grayed out. Those are unused. We can safely remove those. So in this lesson, we have created initialization functions for a couple of resources, for activities resource, as well as timeline items, and both of these functions are contained inside corresponding modules. And all the extra logic that is needed to be executed during the initialization process can be safely encapsulated in these functions. So after doing all those refactoring steps, let's see if our application is still functioning properly. We do not see any errors so far. Looks like everything is good. We can continue development in the next lesson. In this lesson, I would like to do some improvements in regards to timeline items module. So when we open up the application, state of the application is loaded from the local storage, and then we call this initializeTimelineItems function to initialize timeline items reactive variable. So let's take a look what is going on inside of this function. As we can see in here, we're calling a couple of additional functions, such as sync idle seconds as well as reset timeline items, and both of these functions take array of timeline items as the first parameter. But this is not necessary because we have already previously initialized timeline items reactive variable, so we can get access to timeline items array directly within these functions. And also, on the first line of this function, we are searching for the active timeline item object, but there is no need, because we already have active timeline item computed property, which we can use to get access to active timeline item. And as for reset timeline items function, here we are also taking array of timeline items as the first parameter and then iterating over this array. But in fact, there is no need to do it because, as we can see in here, before calling reset timeline items function, we are already initializing timeline items reactive variable with the data that we have fetched from local storage. So now we're going to do some refactoring in here by removing unnecessary parameters. Let's start with sync idle seconds function. I'm going to remove the first parameter from here, as well as declaration of this parameter. And to get access to timeline items array in this function, we can use timeline items reactive variable like so. But as was mentioned previously, this line is not needed because we already have active timeline item computed property. So let's use this computed property right here. Also, the following line is basically doing an update of an active timeline item, but previously in this course we have created function to update timeline item objects. This function is called update timeline item, so let's call it in here. As the first parameter, it accepts that timeline item object we need to update, and as the second argument, it accepts array of overridden fields we have to update. So in here we're basically going to add additional amount of seconds to existing amount of activity seconds of this timeline item object. Let's remove commented code, and as for this conditional, it's not actually necessary, because if we'll take a look at initializeTimelineItems function, in here we are already checking if we have active timeline item, so there is no need to do it again inside sync_seconds function. I'm gonna get rid of this conditional. And just because we are mutating existing object from timeline items array by calling update timeline item function, we don't actually need to return mutated object. So let's remove this return statement as well as this assignment, because original timeline items array is already mutated by calling sync_seconds function. And just as a reminder, update timeline item function looks like this. It just uses method assign to update timeline item object. So now back to reset timeline items function. We're going to do pretty much the same steps by removing this assignment as well as the first parameter. And inside this function, instead of receiving timeline items array as the first parameter, let's reference timeline items reactive variable. And instead of calling method map, we're gonna use for each in this case, because we're going to mutate timeline item objects directly by calling our function update timeline item. So in this case, we are updating two fields, activity seconds and is active. Let's specify those in here. There is no need to return anything from this function, and since this function is private, we can remove this export keyword. So again, let's take a look at initialize timeline items function, and before calling functions sync_seconds or reset timeline items, initially we are initializing reactive variable timeline items with all the data that we have fetched from the local storage, and then those functions will operate on this reactive array. And one final touch to do in this lesson is move reset timeline items function closer to the rest of private functions. And with that, we can finish this lesson and continue development in the next one. So since most part of our application is done, in this lesson I would like to focus on the refactoring. So first of all, we're going to do some tweaks inside timeline stopwatch component. Let's open it up in our editor, and then in the template, let's take a closer look at this Vue directive. This directive is used to hide or show pause stopwatch button. So basically we need to show stopwatch button whenever current stopwatch is running, so users can stop it. And we can actually check it in a different way by using much easier expression in here. So let's just compare current timeline item object that the current stopwatch component is responsible for with an active timeline item object. And this way we can determine if these two objects are the same. That means the stopwatch of the current timeline item object is currently running. Let's scroll at the very top and remove unused import. Now switching over to a different function, stop timeline item timer. This function is called when we press on stop button. As we can see, in order for this function to work properly, we have to pass the first parameter, the timeline item object, which we have to stop the stopwatch for. But there is actually no need to pass this parameter, because inside of stop timeline item timer function, we can easily determine for which timeline item object we have to stop the stopwatch, because stopwatch can only be stopped for the active timeline item object. So in here I'm going to reference active timeline item computed property instead of referencing timeline item passed as the first parameter. So let's remove the first parameter from here. And because we are also calling this stop timeline item timer down here inside of this watch effect closure, let's remove the first parameter and also move this watch effect function to the top of the file before all function declarations. This is how I like to group things. Firstly, I tend to use all Vue primitives, and right after all custom function declarations. We are also no longer referencing timeline item timer constant outside of this module, so we can make this variable private by removing export keyword. And now let's switch over to the storage module and take a look at the implementation of the sync state function. In here we are deciding whether we have to start or stop the timer. And these two functions take active timeline item object as the first parameter. But there is no need to pass active timeline item as a parameter because we have a global computed property that we can reference from inside of any function. So let's remove this parameter from this function as well as from stop timeline item timer function. But we also have to do minor additional modification of start timeline item timer function, because sometimes when we call this function, we do not pass any parameters, and sometimes we do whenever we start timeline item stopwatch manually. In that case, we have to know for which timeline item object we'd like to start stopwatch. But when we are calling this function on the initial page load, inside syncState function, we always wanna start the timer for the active timeline item object. So in that case, we're not passing any parameters. So let's use the following fallback to active timeline item object. And one more thing we're going to do in this lesson is fix one bug related to reset timeline item timer function. So whenever we reset the time of the stopwatch, we also stop the timer. There are actually a couple of scenarios how we can reset the time. First scenario is when we start the timer and then reset the time without actually stopping the stopwatch. In this case, as we can see, everything works fine. But the second scenario is when we start the stopwatch and then stop it and try to reset the time. In this case, as we can see, we are receiving an error in the console. So before actually stopping the stopwatch, we have to make sure that it is running. I'm going to add additional if statement and check if we have active timeline item. Only in that case, we're going to stop the timer. As a reminder, stop timeline item timer function does not accept any parameters anymore. So let's remove this argument. And now back to browser and test this scenario again. Let's start the timer, then stop it and reset the time. In this case, everything worked fine and we didn't get any errors. So let's continue development in the next lesson. We are slowly getting closer to the end of this series. So in this lesson, I would like to do some final improvements and clean up. So let's start with time.js module. In here, let's remove this commented line and directly return current date object from this function. I prefer to still keep this function around because if in the future we will need to modify the current date, we will only have to do this in one place, inside this function, and everywhere where this function is being used, it will return already modified date object. Next, let's scroll to the start current date timer function, and we are modifying reactive variable now, which stores current date, and this date is updated every second. And as we can see, we are currently doing this update by simply adding 1 second to the current date object. And actually we can rewrite this expression in a little bit different way, which is much easier to understand. Since we already have a function which returns current date object, let's just modify our reactive variable now by assigning current date to this variable every second. And this way we're gonna keep reactive variable now up to date. Now let's continue and consider another function, the function which lets us remove activities. Let's open up activity item component, scroll down to delete activity function, and the function which we are currently interested in is called reset timeline item activities. So let's go to the definition. This function is currently defined inside timeline items module, and as we can see in here, we are referencing reactive date object now. But the thing is that this reactive variable now is only updated every second if we are being on the timeline page, because on the timeline page we run the timer which updates every second and therefore modifies our reactive variable now with the current date. But the thing is that this function is only going to be called when we will remove activities, and we can only remove activities being on the activities page, not on the timeline page. So that means that this reactive variable now might get outdated and store the date which does not correspond to the current date. So let's better use another function in here to get new copy of the date object. We already defined such a function which is called today. So let's use it in here as well as in another place where we are referencing reactive variable now. So let's replace this use with the function call today, and then scroll up and remove unused variable now from this import statement. Next, there is a module called validators.js, which groups all validator functions, but during the development, some of these functions have actually become unused. So let's go through all these functions and remove unused ones. We can remove function validate timeline items, as well as validate activities. And also there are a couple of functions which we can make private, since they're not used outside of this validators module. And the functions that we can make private are isNumber or null, isUndefined, as well as function called isNull. And now we're going to run the formatter globally to format all the files inside source folder. We already have an npm script defined inside of package.json. It is this format script. So let's switch over to the terminal, run the following command, npm run format, and this way Proteer is going to format all the files contained within source folder. And with that being done, the project is pretty much ready. The only thing left to do in here is to actually deploy this project to production, which we will do in the final lesson. Recently I have discovered a few bugs in our application, so before actually getting to the deployment, let's fix those bugs first. So one of the discovered bugs that we are going to fix in this lesson is related to the stopwatch. As we know, if we start tracking the time for a particular activity and then current hour changes, the stopwatch should be automatically stopped. But this is only happening in those cases when we have a timeline page open. And if we are being on another page, stopwatch will not be stopped. Let's reproduce this case. And to do this, we will need to modify current date object. So let's switch over to the time module, and right here inside today function, I'm going to modify the current day in the following way by assigning 11 hours, 59 minutes, and 55 seconds. So the current time will be 11:59 AM. And also to make this mutation work, we also have to modify the code inside of setIntervalClosure. Previously, we were manually creating date object based on the date that is stored inside of our reactive variable, and we were modifying this reactive date by adding 1 second. So this code executes every second, and this way every second we're getting new date assigned to the now reactive variable. So now if I'll start tracking the time, in a few seconds the hour will be changed and the stopwatch will be stopped. So this is an expected behavior, but if I'm going to do the same thing by starting stopwatch and then switching to a different page, as we can see, in 5 seconds nothing happens, even though the hour was changed. But stopwatch continues running, so let's firstly figure out what we do to stop the stopwatch if we are being on the timeline page. Inside timeline items timer module, we have this watch effect, which basically keeps track of reactive variable now, and if the hour of the current timeline item is not equal to the hour of the current date, in that case, we're stopping the stopwatch by executing stop timeline item timer function. But the thing is that this reactive variable now only updates every second while we are being on the timeline page, because on the timeline page we start the timer to keep track of the date changes in reactive variable now, and we're doing this by calling start current date timer inside of this onActivated hook, and this onActivated hook is only triggered whenever we open timeline page. And if we are leaving the timeline page, another hook on deactivated gets triggered, and in here we're basically stopping the timer, which keeps track of the date changes. So to make things easier, I'm actually proposing to never stop the timer which updates current date. So we don't need to use this on deactivated hook in here, because we are never going to stop current date timer. And now we don't need to also start timer on this timeline page because we're going to do it right after our application gets loaded. We're only going to execute scroll to current hour in this onActivated hook. Let's also remove all unused import statements and then switch over to main.js, and right here we're going to start current date timer by calling start current date timer function like this. So that means when our application is loaded, we're going to start current date timer, which is basically going to update reactive variable now every second. And just because we're never going to stop this timer, there is no reason to keep stop current date timer function around. We can remove this function from here, and since we're never going to use the reference to the timer which is stored inside current date timer variable, we can remove this variable declaration as well as this assignment to this variable. And also another simplification we can do in here is basically remove this statement which resets reactive variable now, because this start current date timer is only going to be called once on the initial page load, so there is no need to actually reset reactive variable now. And just to improve a little bit code organization in this module, let's just take all this definition of computed properties as well as the reactive variable now and move all of that to the top of the file so that we will have all definitions of our state first, and then all functions will be defined. So now let's see what is going to happen in the browser. First of all, I'll check if our timer is stopped automatically whenever we are being on the timeline page. As we can see, it worked. And now I'm gonna do the same by starting the timer, but this time I'm gonna switch the page, and as we can see, the time is no longer updating because the current hour was changed, and therefore stopwatch was automatically stopped. So this bug is fixed, but there is actually one more which we will work on in the next lesson, and for now I'm going to comment out this code which modifies current date object, because we are still going to do current date modifications in the next lesson in order to fix another bug. Link to the source code of this project will be in the video description. Currently, if we have tracked some time for some activities, when the new day begins, we're actually resetting all tracked time, but all those activities that were previously selected for some timeline item objects, they should remain selected, because we don't want to force users to always assign activities for timeline item hours every day. And actually resetting tracked time happens only when our application loads, but if we're going to keep our application open and the new day begins, the resetting logic will not be triggered, so all this tracked time will remain. And now we're going to work on the fix for this. So let's start. I'm going to modify current date so that our current time will be 23 hours 59 minutes 55 seconds. So 5 seconds before new date begins. And now let's see if we're gonna wait for 5 seconds. Midnight hour becomes active, but previously tracked time still remains. So we actually have to detect when new date begins in real time while our application is running. And in order to do so, we can use watcher and watch for changes in reactive variable now. This variable stores current date and is updated every second. And every time it's updated, it is going to trigger the closure we're going to pass in this function as a second argument. And in turn, Vue will pass two parameters to this closure. The first parameter will be the new date, and the second one will be the previous date. And in our case, just because reactive variable now is updated every second, these two dates will be different only by 1 second. So the way we're going to determine if the new day begins is as follows. We're going to compare hours of both of these dates, before and after, and if they are different, additionally, we're going to check another condition and compare if the hour of the new date equals to midnight hour. This way we will know that the new day has begun. And all we have to do in here to reset all tracked time is to call the function reset timeline items like this. So now let's import all necessary things in this file, and just to see how often this watcher will be triggered, I'm going to put console log statement in here and print out both of these dates after and before. And also let's see when we will get into this if conditional. I'm going to put in here console log statement as well. And now let's switch over to the browser. As we can see, watcher is triggered every second, but reset timeline items log only appears when the new day begins. And also we can notice that the time for the last timeline item was reset when the new day began. So let's just remove those previously added console log statements. And we actually have one more issue we have to fix before finishing this lesson. And that is this: if I'll start tracking the time and we'll keep this stopwatch running after new day begins, we can see that the time is still increasing, even though the stopwatch was stopped. And this happens due to the following reason. Inside timeline item timer module, we have registered this watch effect, and whenever new day begins, we're calling stop timeline item timer to stop running timer. But looks like that this function gets called after we are calling this function reset timeline items in another watcher. And just to make both of these functions to be called in the proper order, let's just combine these two watchers. I'm going to cut all this code and put it inside this watcher, but before calling reset timeline items function. Therefore, the previous watch effect function can be removed now. So now these functions will be called in the proper order when the new day begins. Let's just remove all unnecessary imports and test this functionality out. I'm going to start tracking the time, and as we can see, after a couple of seconds, the new day has begun and stopwatch was stopped. And at the same time, tracked time was also reset. So now everything is working properly. So we'll just have to go back to time.js module, and we were previously mutating the current date. Let's just discard all these changes and return current date object like this. And also, since in the previous lesson we have modified the function inside setInterval, which is triggered every second, to modify a reactive object now. This was only needed to properly mock current date, but since we're not going to mock it anymore, we can get back our previous implementation. And there is actually one more thing that I would like to simplify, and that is inside this function watch, we are referencing a reactive variable now, but in fact, since Vue automatically passes updated date as the first parameter in this closure, instead of references this reactive variable, we can reference this parameter after, and the result will be the same. And at this point, let's finish this lesson. The link to the source code of this repository will be in the video description. Finally, we have reached the last lesson of this course, where we're going to see how to deploy our application to production. And since our application is based on Vue build tool, let's open up Vue documentation. Specifically, we need deployment page. And here we can see several deployment options with using different service providers. And we are going to use the service called Search. First of all, we'll have to install a Search command line tool. So let's open up Search documentation and see what we need to run in order to install CLI. Before installing this CLI, we also have to ensure that we currently have Node.js installed. And right after, we can run the following command, which is going to install Search CLI globally in our system. So I'm going to run this command in my terminal. As we can see, we're getting permission issue. So let's rerun this command with specifying word sudo in front of this command. And this way, this command will be executed with admin privileges. This time everything worked well. On the next step, we'll need to build our project, and we can do so by running the following command: npm run build. Let's switch over back to the terminal and build the project. By default, Vue generates build version of the project within folder called dist. And now that we have our build, we can use search CLI to deploy this folder. So let's run the command search, and here we need to specify which folder we will deploy. It is called dist. And if we don't have search account yet, this utility will propose us to create one. But if we already have an account, we just need to log in by providing email and password. That is the domain where our application will be globally available on the web. And if we'll switch over to the browser and open up this URL, indeed, we can see our application was successfully deployed. But in case we need to use our custom domain name, there is custom documentation page which shows how to configure a custom domain name. And also this page includes links to popular domain providers with instructions that are specific to those providers. I have already gone ahead and configured custom domain name, so this project will also be available under the following domain name. And with that, we're finishing this course. Thanks for watching.